Welcome to qnawire.
We assume that the tensions in the two unbroken cables immediately become zero, and so they have no effect on the motion. The forces on the tower are the forces at the base joint and the weight mg. The axis of rotation is through the point of attachment to the ground. Now, since that axis is fixed in an inertial system, we can use equation 11.9 in one dimension. So we have net torque to be equal to dl over dt. Now you can see the free body diagram given in the text to express the torque. So you'll find that the torque is mg times half L sine theta. So this is the force, this is R, and this is theta, which is where theta is the angle between F and R. Basically, we are using torque to be equal to F cross R, which is F times R times sine theta. So this is the magnitude. So this is in fact equal to dl over dt. This is capital L and this is small l. Now we know that the angular momentum is I times omega. Since I is a constant here, we can write this term to be I times d omega over dt. And also one thing, I here is 1 over 3 ml square because the cable is, yeah, this is 1 over 3 ml square. Now because it's rotating about one of the corners, not from the middle. Now we can write the resultant equation. This is equal to 1 over 3 ml square times d omega over dt. And some of the terms cancel here, so m cancels, one of the L cancel out. So now we have also omega is rate of change of theta. So now we can express omega in terms of theta now. So then we have 1 over 2 g sine theta to be equal to L over 3 d theta square, sorry, d square theta over dt square. Now let's just keep in mind this equation and let's call it equation 1. Now this equation could be considered, but it would yield theta as a function of time. Therefore, we use chain rule to eliminate the time dependence over here. So to do that, so let me just write the equation that we got in this page again. And this was d omega over dt before. Now we can express d omega over dt like this. We'll understand in a minute as to why we are doing this. Again, d theta over dt is omega. So this is omega and then we have d omega d theta. That is this term. Now if we plug this value of d omega over dt instead of the double differentiation, we will have the resultant equation independent of time, which will make our calculations much easier. So we will use that equation, we will use this equation instead of equation 1. Also, this equation is relatively simpler to solve because it is a single differentiation equation, and this was a double differentiation equation. So, also, so there are two reasons as to why we cannot use this equation. Now, let me just set aside the components that we are going to integrate. So, we have omega d omega on one side. Let's just take all of these terms onto the other side. So we will have 3g over 2 sine theta d theta. Now this part is a constant, so we integrate both the sides. So this will go from 0 to omega, and this should go from 0 to theta. Therefore, we have omega square over 2 to be equal to 3g over 2, and integration over sine theta gives cos theta. So we have cos theta, and the limits go from 0 to theta. So this is equal to cos theta minus 1. So if you are getting confused with this theta and the theta in the integral, you can change this theta to theta dash because this is just a variable. So, and then you can integrate taking the limits to be theta. Now this 2 in the denominator cancel out. So we have omega square to be equal to 3g over L 1 minus cos theta. Therefore, omega is equal to 3g over L 1 minus cos theta. And we have to take the root over because of the square here. Now, we know that velocity is r times omega. This means that omega is equal to v over r, and r here is basically the length. So we will use this equation over here to find the velocity. So v will then be equal to, v over L will be equal to 3g over L times 1 minus cos theta root over. This gives an expression for GL, which we can solve now to determine the velocity. So we have G, which is equal to the gravity. L is given to be equal to 12 meter. And we have 1 minus cos theta. I'm just separating the root overs because I'm not going to solve this. Now we have V to be equal to 19 times 1 minus cos theta root over. So this is the final expression for the velocity. Note that the same result for V can be obtained using conservation of energy, since the forces at the ground, they don't do any work. So you can obtain the same expression using a different approach using conservation of energy if you want to.